Class, what is up? Today we are going to recap some ideas of logarithms so that you can take a little take-home quiz. So this video shouldn't be too long, and we'll see how I do on that. All right. So far we should be able to do the following things. All right. We need to be able to solve by making common bases. So I look at 4. I look at 16. I recognize that I can make both of these have a base of 4. What do I do to make this 4? Nothing at all. It already is. 1 over 16? Well, I can change that to what? What if it was just a 16? Well, then it would be 4 squared. But it's in the denominator, so I have to raise it to the negative second power. Alright, and then now I have common bases, so I'm good to go. I set my exponents equal. I start to solve. Perfect. Alright, so again, once you get these common bases, then you can set the exponents equal and you can solve. Now in something like number 2, this graph, first thing we notice, I have a couple of negatives. Alright, so this one would mean I'm going to flip over x. This one would actually mean I'm going to flip over y. But if you remember, what's going to be easier? What's going to be easier when we graph an exponential function and we have a negative x or a negative exponent? Yeah, I'm going to rewrite this and I'm going to change this to be y equals negative. E to the negative x is the same as 1 over e to the positive x. Alright, so this is going to be way easier to graph. Why is that going to be easier to graph? Because I now can just plug in my nice x values because I see an x. Alright, so remember we go negative 1, 0, 1. When I plug in 0, anything to the 0th power is going to be 1. However, there's a negative out front. Alright, and we knew that it was going to flip over x. So that needs to be a negative 1, not a positive 1. When I plug in positive 1, well, 1 over e to the first is 1 over e. But again, it has to be negative, so negative 1 over e. And lastly, 1 over e to the negative 1 is e. However, it's negative, so negative e. Alright, now that you have these 3 points, just do the absolute very best job you can to plot them. So 0, negative 1 is nice and easy. Negative 1, negative e, you guys got to remember, e is about 2.7. Excuse me. So, negative e would be about there. And then lastly, negative 1 over e, negative 1 over 2.7, I'm thinking that's around 0.2, so I just do my, negative 0.2, so I just do my best job I can to sketch that, and I draw in my exponential. If you want, remember there is a horizontal asymptote, so that's not a bad idea. If you need to sketch that to remember that it's there, do it. Okay, 3, finding the domain. Remember, do not worry about anything but the argument of the log. Okay, the argument is right here. It's what we're taking the log of, and I know that whatever we're taking the log of must be greater than 0. So x minus 4 must be greater than 0. X is greater than 4. Nice and easy. Let's do one more that's a little more challenging. Same thing though. I see my argument is x squared minus 25, which must be greater than 0. I would go with x minus 5, x plus 5 is greater than 0. These are my critical values, so I plot them. It has to be greater than 0, so I have to leave open circles, because if I put a negative 5 or a 5, it will make it exactly 0, and that is not greater. Now I test. Let's see here. If I negative 10. Negative 10 squared is 100. 100 minus 25 is 75. That's greater than 0. So I like it. The other option there, you could just plug in a negative 10 and a negative 10, which would be negative and negative or positive. and that's what we're looking for. Now if we plug in 0, you'll have a negative times a positive. Oops, sorry, that's a negative, so we don't want that. And then positive times positive is positive. If I plug in 10, it's a positive and a positive, so I shade there. So the last thing we would have to say then, guys, is we have to write out, probably using interval notation. So I would maybe say negative infinity to negative 5 union 5 to infinity. And I'll say domain. Alright? Okay. Now, for the next few, lots of solving, lots of rewriting. Alright? If I have a logarithm, I can always change it to exponential form using the log circle. What do we say? If we have log base 1/4 of 64 is equal to negative 3, well then we have the base raised to this power will equal the argument. Alright, so 1/4 to the negative third is equal to 64. And that's all you need to do for that. Changing from exponential to logarithm form can do the same exact thing. The circle kind of works again. This time, however, we need to write it something like this, okay? So again, the base will stay, but we need to basically say we're going to, or the power goes over here. And then the argument goes right there. Alright, so again, notice the circle works the same way. What did I do? I took the log of base 6 of 1/36 is equal to negative 2. Alright. Using change of base, hopefully we remember that when we see something like this, we can't really just put that into the calculator. We need to use the change of base, which basically just means that you take the log of the argument over the log of the base. Alright, so something like that. Could you use ln? Sure. If you wanted, you could use ln 27 over ln 8. These would be the same thing. And both of them, what do we got? Log 27 divided by log 8, 1.58. Let's just double check this so you guys believe me. Doesn't matter which log you use, but we would write 1.585, or approximately, I should say. Alright. Okay. Now we get into some solving. Alright, we're going to basically be solving for the rest of this video. We have to go over some of our different procedures or concepts or procedures to solve. My bad. When I give you an equation with just a single log on one side, I would just use a log circle, something like this, or even number 9. The easiest way to do this would be to take your logarithm, change it into exponential. Alright, so we're going to say 42 to the first power is equal to x squared minus x. Okay, if we keep going, just 42 equals x squared minus x, or 0 equals x squared minus x minus 42. You see where we're going? When we factor, we end up getting that x can be negative 6 or 7. Now the last thing you have to do, you have to make sure that neither of your answers, or solutions I should say, are extraneous. Okay, so you plug negative 6 back in, that's good. When you plug negative 6 in, that stays positive, and same thing with 7. So I would box both of these answers. Neither of them are extraneous. Alright, now on something like 9, again I see a single logarithm on the left side, which is good. We're going to do a little bit of work first though. We want to just get this log, natural log I should say, of 6x by itself. Right now there's this 4. It's the exponent of the argument, and hopefully you guys remember whenever you see that, you can always bring it out front. So I'm going to change this to 4 ln of 6x equals 28, because then hopefully you guys agree with me that I can rewrite as that. And now that we have this nice logarithm, there's no extra exponents or anything, now it's the same thing as number 8, guys. It's the same thing. We're going to use our log circle. Now you need to remember, a natural log has what base? I don't see it, but we know it's there. It's like there's an e there. So I use my log circle, and I say that e to the 7th power must equal 6x. And finally, x equals e to the 7th over 6. And I would leave it just like that, because that is a perfect, exact answer. Alright, we're getting there. Number 10 is extremely similar to the very first problem. We knew that if we had common bases, the exponents were equal. We now also have learned that if we have common bases for logs, then the arguments will be equal. So because these both have a base of 6, I'm going to just set the arguments equal to each other. So let's see here, what is that? 5 equals x. There it is. Got it. Done. Alright, last two, probably the most difficult, but again, nothing impossible. You can do these. In both of these, what I need you to recognize, I really technically have 3 pieces, 2 of which are logs, so I need to combine these 2 logs into 1 in order for me to be able to use a log circle. Alright? In order for us to use our solving methods, we need to turn 2 logs into 1. And hopefully we agree or remember. What can we do? I see 2 logs separated by addition. If you remember correctly, when you see 2 logs separated by addition, that means that you can combine them, the arguments, using multiplication. Alright? So, what did I do? I multiplied x and x minus 24. I distribute it, and now I have a single log, so I can log circle. Alright, so let's see here. What do we have? 27. Oh, what am I doing? Sorry. 81 equals x squared minus 24x. Okay. Sorry about that, guys. Okay, so 0 equals x squared minus 24x minus 81. And when we come over here, we need to factor this. I know it's not the easiest one to factor, but this is definitely doable. Can't be 9 and 9. Can't be 9 and 9, but I'm thinking negative 27 and positive 3. Alright, so we know negative 3, positive 27. Those are our possible answers. Now, you need to again check for extraneous solutions, and I see one. I have log with just the argument of x. So if I plug in this negative 3, it makes my argument negative, and we can't have it. Alright? You cannot do it. That is extraneous. So my only solution here is 27. Alright, last problem. Almost done. Okay, again, I see 3 pieces. I see 2 logarithms with the same base. So what am I going to do? I'm going to have to get these logs, or turn these logs into a single logarithm. So what can I do there? Let's see. I think I'm going to move this guy over to the other side. So I have log base 6 x minus 5 plus log base 6 of x equals 2. And then I start to rewrite, so I can combine these, same idea. 2 logs with addition means I can multiply their arguments. And then I can log circle. That's the end goal, right? If you have multiple logarithms, get it into one, because then we can log circle. 6 squared equals x squared minus 5x. 36 equals x squared minus 5x. I know I'm running out of room here. Let's see here. 0 equals x squared minus 5x minus 36. So we know that that factors x minus 9, x plus 4. Okay, I'm going to change colors just because I know I'm running out of room and I'm getting messy. So now I know x should be negative 4 or positive 9. And then, of course, you need to check. You have to check. I already know, just looking, I cannot use negative 4. That will be extraneous, so I cross it off and I say x equals 9. All right, so there is a recap on everything that you should be able to do on logarithms at this point. Have a good one.